by general principle and process of isolation of elements. Okay, so let's get started. And this one is what I have made. Okay, I will give the picture. General principle and process of isolation of elements. Minerals are naturally occurring chemical substances in the earth crust obtained by mining. Ores are the minerals from which metals can be extracted profitably and conventionally. The entire scientific and technological process used for isolation of the metal from its ore is known as metallurgy. Metallurgy of a metal involves three main steps: concentration or dressing of the ore or benefaction, isolation of the crude metal, and purification of the or refining of metal. Concentration, isolation and purification. Concentration, isolation and purification are the three steps. Concentration of ores. The undesired impurities such as sand, clay, rocks, etc. associated with the ore are called gangue or matrix. The removal of these impurities from the ores is known as concentration, dressing or benefaction of ores. The concentration is done in a number of ways depending upon the nature of impurities. Hydraulic washing is based on differences in gravities of the ore and gangue. Electromagnetic separation is based on differences in magnetic properties of ore and gangue. Growth flotation process is based on preferential wetting of ore particles by oil and gangue particles by water. Preferential wetting of gangue particle by water and ore particle by oil, OO, ore by oil and gangue by water, OO. Collect and is mainly done for sulfide ores. Collectors, fine oil, fatty acids and xanthates enhance non-wettability of mineral particles. Froth stabilizer, cresols, aniline stabilize the froth. Depressants are added to separate two sulfide ores. In case of an ore containing ZnS and PbS, the depressant used is NaCN. It selectively prevents ZnS from coming to the froth but allows PbS to come with the froth. PbS comes in the froth. When NaCN is used, then PbS comes in the froth and ZnS go in the solution. While in froth flotation method, depressant is used when two sulfide ores have to be separated. Okay. And here the froth stabilizers are cresol and aniline, and collectors are pine oil, fatty acids and xanthate, which increase the non-wettability of ore particles. Leaching is based on solubility of ore in a suitable solvent and involves the treatment of ore with a reagent to make it soluble with impurities remains insoluble. The ore or the metal is recovered by solution by a suitable chemical method. Extraction of crude metal from concentrated ore involves the following two steps. Conversion to oxide. Calcination involves heating of the ore below its fusion temperature in absence of air. Below its fusion temperature in absence of air, calcination is done. The steps expels organic matter and moisture from the ores and is mainly used to convert carbonate and hydrated oxides or to their respective oxides. Carbonate and hydrated oxides, calcination is used, which is done below its fusion temperature and in absence of air. Roasting involves heating of the ore in presence of oxygen below its fusion temperature and it generally converts sulfide ore to their oxides. Roasting for sulfides and calcination for carbonates and hydrated oxide ores. Reduction of oxide to metal is done by a suitable reducing agent. Following methods can be applied: smelting, pyrometallurgy, gold sigmid, aluminothermic process, reduction by alumina self or auto reduction process, electrolytic reduction, hydrometallurgy. Reduction of oxides of the metal, smelting. The process of extracting metal by heating the metal oxide with carbon in form of coke, charcoal or carbon monoxide. Pyrometallurgy. The process of extracting the metal by heating the metal oxide with suitable reducing agents such as carbon, hydrogen and CO, water gas, Na, K, MgAl, etc. Gold seismic aluminothermic process, reduction by alumina. The process is used in the case of those metals which have very high melting points and are to be extracted from their oxides. Auto or self-reduction process. The sulfide ores of less electropositive metal like Hg, Pb, Cu, etc. are heated in air so as to convert a part of the ore into oxides or sulfates, which then reacts with remaining sulfide ore to give the metal and SO2. Electrolytic reduction. The highly electropositive metals such as alkali metals, alkaline earth metals, etc. are extracted by the electrolysis of their hydroxides, chlorides and oxides in the fused state. Electrolytic reduction is for highly electropositive metals, alkali earth metals. Hydrometallurgy. Certain metals such as silver and gold are extracted by dissolving the concentrated ore in some suitable reagent and then recovering the metal from the solution by treatment with some more electropositive metal. Electrolytic reduction is for highly electropositive metals and hydrometallurgy is for gold and silver. Okay. Thermodynamic principles of metallurgy. Thermodynamics helps in understanding the conditions of temperature and selecting suitable reducing agent in a metallurgical process. Gibbs-Helmholtz equation is used to check the feasibility of a reduction. Since we know that delta G degree equal to delta H degree minus T degree S. If delta G is smaller than 0 or delta G is negative, the reduction is feasible or reaction is possible or reduction is possible. For a reaction, enthalpy change is fixed but temperature factor could be controlled and be the deciding factor for feasibility of that reaction. Coupled reaction. If reactants and products of two reactions are put together in a system and the net delta G of two possible reactants is negative, the overall reaction will take place. These reactions are called coupled reactions. Allingham diagram. Allingham's diagrams, the plots between delta G degree of oxides of elements versus temperature are called Allingham diagrams. It provides a sound idea about selecting a reducing agent in reduction of oxides. Such diagrams help in predicting the feasibility of thermal reduction of an ore. Delta G must be negative at a temperature for a reaction to be feasible. Okay, application of Allingham diagram. Allingham diagram for formation of FeO from Fe, CO from CO, C and CO2 from CO. Allingham diagram showing the formation of Cu2O from Cu, Zn from Zn and CO from C and CO2 from C and CO. So those which are at lower temperature can, those which are having lower delta G can reduce those which are having less delta G. Like you can see those which are at minus 500 and those are having minus 100. So minus 500 will reduce those which are at minus 100. Okay. Like MgO and Al. Electrochemical preparation principles of metallurgy. Electrolysis is used to carry out the reduction of a molten metal salt to a molten metal salt. Okay. Electrochemical principles of metallurgy. Electrolysis is used to carry out the reduction of a molten metal salt. The electrochemical principle of this method can be understood through the equation delta G degree equal to minus NFE degree cell. More reactive metals have large negative value of electrode potential, so their reduction is difficult. More reactive metals like alkali metals, alkali earth metals are having large negative value of electrode potential, so their reduction is difficult. If the difference of two delta 2 E degree values corresponds to a positive E degree and a consequently negative delta G, then the less reactive metal will come out of the solution and the more reactive metal will go to the solution. For delta G to be negative, E should be positive. Purification or refining of metal. The process of purification purifying impure metals is called refining. The various processes used for refining are distillation. The process is used for those metals which are volatile, ZnCd and Hg. ZnCd and Hg distillation. The impure metal is heated and the vapors are separately condensed in a receiver. Liquation. The process is based on differences in fusibility of the metal and impurities. When the impurities are less fusible, higher melting than the metal Sn and Pb itself, this process is used. Cupellation. You can learn it by ML. Melting liquation, ML. Sn and Pb. Cupellation. The impure metal is heated in a couple or oval shaped crucible made of bone ash or cement, and a blast of air is passed over the molten mass. The impurities are oxidized and removed with the blast of air. Pooling. It is used for purification of those metals which contains their own oxides as impurity. Cu2O in blister copper and Sn2O in crude tin. The molten impure metal is stirred with green coals of wood. Electro-refining. Electro-refining metals like Cu, Ag, Au, Ni, Cr, Al are purified by this method. The impure metal is made anode. You can learn it by IMA, Indian Medical Association. Impure metal is anode. And you can learn, and strips of pure metal is made cathode. Personal computer PC, pure metal cathode, and impure metal is anode. While electrolytic solution consists of a solution of a soluble salt of the metal. Zone refining. When highly pure metals are required, this method is used for purification. Highly pure metals. Zone refining is used for highly pure metals. It is based on the differences in solubilities of impurities in molten and solid state of the metal. Semiconductors like SiGe and germanium and gallium are purified by this method. Zone refining is for semiconductors and it depends on the differences in solubilities of impurities in molten and solid state of the metal. Okay. Vapor phase refining. Van Arkel method and Mond's process. Van Arkel method. This method is used for obtaining ultra pure titanium and zinc-corium, etc. are refined by this method. Impure metal plus I2 give metal iodide vapors. Heating with tungsten filament. Pure metal plus I2. Van Arkel is for Ti and Zr. Titanium and zinc-corium. Aeroplanes. Mond's process. Nickel is purified by this method. The impure nickel is treated with CO at 330 to 350 K. Volatile nickel carbonyl is formed. The carbonyl is subjected to 450 to 470 K. It decomposes giving pure nickel. Ni plus CO. Ni, which is impure, reacts with 4CO2 at 330 to 350 K giving Ni CO whole 4 volatile complex 450 to 470 K Ni pure plus 4CO. Okay. Chromatographic method. This method is based on the principle that different components of a mixture are differently adsorbed on adsorbent. Lanthanoids are purified by using ion exchange as adsorbent. Thank you. This was all about general principle and process of isolation of elements, and all the best for your examinations. Okay.